of course, if the concept is known. Now, having two vectors A and B, the scalar projection of B on A is written as projection of B on A, right? This is the scalar projection of B on the vector A, and this is written as the magnitude of B, the magnitude of B cos theta. Now, we can actually derive quite a number of formulas from this. The first being A dot B being equal to the magnitude of A, the magnitude of B cos theta. Now, remember that the projection of B on A is given by B cos theta. Therefore, we can divide both sides of our equation by the magnitude of A. A cancels out, leaving us with the projection of B on A or B on A being equal to the dot product of B on A, and this is also equal to the magnitude of B cos theta. Now, we can use any of these two in calculations. Now, this is used when we have when both of the vectors A and B are given. Then we can find the magnitude of A and simply use that to find the projection of B on A. Now, this is also useful when we have the angle between the two vectors, right? Then we can simply find the magnitude of B and simplify our expression, right? Now, this is the scalar projection of B on A. There is a difference, a big difference between scalar projection and vector projection. What we have over here is the scalar projection, and now we are going to be looking at the vector projection and take some examples, so please don't go anywhere. Now, for the scalar projection, for the vector projection, vector projection, the vector projection has its magnitude to be the scalar projection, right? It has its magnitude as the scalar projection. What do we mean by this? Now, in simple terms, the vector projection is given by the expression the unit vector of A and the projection, the unit vector of A and the projection of B on A. Now, this is the magnitude of the vector and this is its direction. And remember, this is the scalar projection. That is why I said earlier, the magnitude of the vector projection is equal to the magnitude of the vector projection is actually equal to the magnitude is actually equal to the scalar projection is equal to the magnitude of the vector projection. I hope you got it. Yes. Now, remember that we obtain from the scalar projection that the projection of B on A is given by B cos theta, right? And B cos theta, of course, is equal to A dot B on the magnitude of B cos theta, and this is equal to the magnitude of A, right? Now, therefore, finding the vector projection, the only thing we have to do is to find the unit vector of A, which is given by the vector A on its magnitude, right? And after, we multiply it by either B cos theta or A dot B cos theta. I know this is looking like a lot, but it's actually not a lot. We'll be taking a lot of examples, so please stay tuned. Now, take note of this. For the scalar projection, right, your answer should be in single terms. What do I mean by that? You can get something like 7 units, 8 units, 10 units. But for vector projection, your final answer should be in a form of a vector, right? Because you are multiplying the scalar projection by a unit vector. Okay, so your final answer should have an I component, a j component, or a k component. Of course, some of the components must be zero, but you should have at least one component present, right? But for the scalar projection, you don't get any of the components. You get values like 7, 8, 9, 10, right? Now we are going to be taking an example and we will be concluding. Now we have this example. Given the vectors A is equal to 6i minus 3j plus 2k and B being equal to 2i plus k, find the scalar and vector projections of B on A. Remember, we write the projection of B on A as projection of B on A, right? So the B comes first and the A follows. And as we discussed earlier, this is equal to B dot A all on the magnitude of A, right? So now let's find the dot product of B and A. So the dot product of B on A, we simply take the I component and multiply it with this I component. So 6 times 6 times 12 gives us 12. And also, we take this J component and multiply it with its corresponding J component. And now the J component here is 0, right? Because it hasn't been given. So the J component here is 0. So plus 0 plus the K component. So 2 times 1. Of course, this gives us 2. And we obtain 14 for the dot product B dot A, right? You obtain 14 units. Now, how can we find the magnitude of A? The magnitude of A is equal to 6 squared, which is 36, plus 9, because we are squaring the entire -3 expression, which gives us 9, plus 4, right? Now, 36 plus 9 gives us 45, and 45 plus 4 gives us the square root, gives us 49, right? So the square root of 49 gives us 7, right? Now that we found our B dot A and our magnitude of A, we can find the projection of B on A. And this is equal to 14 on, on 7. Sorry, I was in a bit of a hurry, and this gives us 2. And as I said earlier, in finding the scalar projection, always expect a single digit um, number as an answer, right? Sometimes you get an expression, but most often it should not be in vector form. Now let's find the vector projection of B on A. As we discussed earlier, the vector projection of B on A has its magnitude to be the scalar projection, right? So now the vector projection of B on A is given by the unit vector A multiplying the projection of B on A, right? And this is equal to the unit vector of A, which we are here to find, multiplying the projection of B on A. Now this is the projection of B on A, and we obtain is to be 2, right? 2. So all we have to find is the unit vector of A and multiply it with 2. Now the unit vector of A, to find the unit vector of A, we have to take the vector A, 6i minus 3j plus 2k, right? And divide it with the expression, the magnitude of A, right? And the magnitude of A gives us 36 plus 9 times 4, right? Of course. And this gives us the square root of 49. Let me continue over here. Because all this is multiplied by 2. So now we obtain 6I minus 3j plus 2k on the square root of 49, which is 7, and this entire expression times 2, right? Now this is our final expression for the vector projection of B on A. This is our final expression for the vector projection of B on A. And remember, as we said, they should always be in a vector form. Thanks you everyone for watching. Sorry I wasn't that fluent. Please subscribe to be kept updated. Thank you. See you soon.